What are isotopes? Atoms of the same element having a different number of neutrons in the nucleus is what we call as isotopes. For example, we have a carbon, atomic number is 6 and atomic mass is 12. Here this 12 actually represents the number of protons and the neutrons. This is the nuclear number, and this one represents the number of protons here. Alright, so that means this carbon 12 element has 12 atomic mass. That means it has 6 protons. Total number of neutrons and protons is 12. That means neutrons must be there. 12 minus 6, which is 6. Right? And electrons, since the molecule, its atom is neutral, the number of protons is always equal to number of electrons, so it will have 6 electrons. 6 protons, 6 neutrons, and 6 electrons. Another isotope of the carbon is carbon 13. Right? The nuclear number here, the atomic mass here is 13. That means number of neutron and proton is 13. Protons again are 6. Atomic mass is 6, so protons are 6. Neutrons must be, neutron number must be, that is 13 minus 6, which is equal to 7. So that means this, carbon 13 has 6 protons, 7 neutrons, and 6 electrons. Another isotope of the carbon is C14. Right? C14. So protons again 6. Neutrons must be 14 minus 6, that is 8. And electrons will be 6. So that means isotopes have the same atomic number, because atomic number represents the number of protons, but different mass number. Right? Why the mass number is different? Because the number of neutrons are different. Alright? So that means the 3 isotopes of the carbon, here the carbon 12, carbon 13, carbon 14, they have the same atomic number. That means the same number of protons, same number of electrons, but difference is the number of neutrons. Alright? So isotopes have the same atomic number, number of protons, and the name of the element again remains the same. But what is different? Different is the number of neutrons, right? And that will also have a difference in the atomic mass as well. The 3 isotopes of the hydrogen are protium, deuterium, and tritium. Hydrogen H11, H12, and tritium H13 means that hydrogen H11 proton is 1, neutron 1 minus 1 is 0, electron is 1. Deuterium protons 1 because atomic number is 1. Neutron must be 2 minus the mass number, 2 minus 1, that is 1, and electron is again 1. Tritium proton again 1, neutron is 3 minus 1, that is 2, and electron here is 1. Right? So they have the same atomic number, number of protons is same, number of electrons is same, but difference is the number of neutrons, and that will have a difference in the atomic mass as well. Isotopes of the nitrogen N14, 13, and 15. Nitrogen atomic number 7, and one of the isotope is N13, another isotope is N14, another one is N15. Right? So that means here the number of protons 7, neutrons 13 minus 7, that is 6, and electrons equal to the number of protons, which is 7 again. So protons here are 7, neutrons 14 minus 7, that is 7, and electrons here again 7. Nitrogen atomic number 7, atomic mass is 15. So that means number of neutrons here will be 15 minus 7, that is 8. 8 protons, and electrons again equal to the number of protons, that is 7. So we find again the difference in the number of neutrons, and because of the difference in the number of neutrons, the nucleon number here is different. Isotopes of chlorine. The two important isotopes of chlorine are chlorine 35 and chlorine 37. So chlorine with the atomic number 17, therefore the number of protons are 70. Neutrons here must be 35 minus 17, which is 18. So neutrons are 18, electrons again they are 70. Chlorine 37, protons here in this case must be again 17, atomic number is 17. Neutrons must be 37 minus 17, which is 20. And electrons here are 17 again.